This is a lecture on decimal to octal number conversion. Now, the decimal number system uses 10 symbols 0, 1, 2, 3 up to 9. And since there are 10 symbols, we say that the base or radix of the system is 10. The octal number system, on the other hand, uses symbols 0, 1, 2, 3 up to 7. That means there are 8 symbols used in this system, and therefore the base or radix is 8. We'll see that symbols like 8 and 9 are not valid in the octal number system. Let us see what is the advantage and disadvantage of octal numbers. The major advantage of octal number is that a set of 3 bits or binary digits can be represented as a single octal digit. This leads to a more compact notation. For example, consider a binary number 101. This occupies 3 bits, but the same number can be represented by the single symbol 5 in the octal number. In another lesson, we'll be learning how to convert from octal to binary and vice versa. But octal numbers have a disadvantage in that a computer system doesn't really understand octal numbers. The native language of a computer is the binary language. Let us now take one example of how to convert a decimal number to its octal equivalent. The method is outlined here, and we'll go through this one step at a time to understand how to bring about this conversion. So we have a decimal number 295. This is our original number, and this 295, since it is in the decimal system, we have represented it as 295 with a subscript of 10, and we want to convert it into the base 8, and that is why the subscript shown here is 8, and this is the number that we need to calculate. Now the method is very simple. We will create 3 columns here. The first column will contain our divisor, which is going to be 8. The second column contains our original number. This original number that we have is 295. The third column we have marked as remainder. Now let us start by understanding how we bring about this conversion. We will divide the decimal number by 8. The number that is given to us is 295. We will keep dividing this by 8. So 8 goes 36 times and the remainder is 7. So 8 3 times is 24. That leaves a remainder of 5. That leaves a 5 remainder, and 8 6 is 48, which leaves a remainder of 7. So we have a remainder of 7 right now, and the quotient that we have is 36. Now we will continue this process till we get a quotient of 0. So we'll go back and we will repeat this step where we divide the decimal number again by 8. Now our decimal number now is 36. So 8 4 times is 32, and that leaves us with a remainder of 4. Since the quotient is not yet 0, we'll again go back and divide this by 8. Now observe this. 4 is less than 8. So 4 cannot be divided by 8. So we'll say 8 0 times is 0, and that leaves us with a remainder of 4. Now the quotient has become 0. So we will take all these remainders in the reverse order, and we will get the number 295 of decimal. It can be expressed as the number 447 of octal. One must be careful here not to pronounce this as, not to read it as 447, because this is not really a number in decimal, it's in octal number system, and this becomes your final answer. Let us consider another example here, which is to convert a decimal number to its octal equivalent, and the number that we have is a fractional value of 0.3125. Now we make 4 columns here. The first column is having the title number, the second column we mark it as multiplier, the third column fractional value, and the fourth column is carry. Now we will write down the original number given to us 0.3125 in the first column. In this column we will write down 8. So we are multiplying the number 0.3125 with 8. When we carry out this multiplication, we get the fractional value 0.500, and the carry is 2, because 8 times 0.3125. This is 0.3125 times 8. This is going to be 8 5 times is 40, 0 with a carry of 4, 8 2 times is 16, and 4 is 20, 0. This is 2, 8 1 times is 8, and 2 10, 0 with a carry of 1, 8 3 times is 24, plus 1 25, so 5, and with a carry of 2. So we get 2.500. So the fractional part of 0.500 we have written here, and the carry is shown here in the last column. Now we will continue this process till we get a fractional value of 0. So we will copy this value 0.500 into the first column. So this value we bring it down into the first column, okay, and again continue with the multiplication by 8. So 0.500 multiplied by 8, this is 0.0000, but of course there is a carry of 4. So we have here 0.5000 multiplied by 8. So this is 80, 80 times 0, 80 times 0, 85 times is 40, 0 with a carry of 4. So we write the fractional part 0.00 in the column here, and the carry becomes 4. And now since we have the fractional value of 0, we can stop the process. We consider the carry values in the forward order, and our final result becomes 0.3125 of decimal is equivalent to 0.24 of octal. Let us now consider a mixed number. In this number, we have the decimal value 295.3125. Now, this number conversion can be done by using the methods of the previous two examples. So, the first part 295, we separate it out, and this 295 of decimal we convert it by the previous method, and this becomes 447 of base 8. We did this in the first example. Now we convert the fractional part 0.3125. This 0.3125, which is of decimal, we just now converted it and we got the value of 0.24, and therefore the final answer becomes 447. So we take the integral part, the octal integral part 447, and 0.24 is the fractional part, and we write 24. So we have 447.24, and this point that we put here, it is similar to a decimal point, but only in this case, because we are in base 8 or in the octal base, we will call it as an octal point. So this becomes the method of conversion from decimal to octal.